Welcome in, everyone. Thank you for joining us today. We'll give it a few minutes before we get started. Just while we're waiting, if you want to let us know in the chat whereabouts in the world it's from, it'd be great to see how many different people got. While we do that as well, just on the next slide, we've got a couple of links to the previous webinars we've run. We've got the first one there is the previous webinar in this series where we talk about launching, scaling, and all those things to consider when doing that with a multiplayer game. And we've got one is an introduction to our game server hosting and matchmaker products. So they give you an overview of what they are, how to use them. So if you haven't seen any of those, then please scan those codes and save those to watch at a later date. As I said, we'll give it a couple of minutes, let some people join in, and then we'll get started. Take a quick look of where we've got people from. So, UK, as myself, Spain, Pakistan, Hamburg in Germany, US, Chile, France, Brazil, Austria. Whoa, all over the place. Somewhere in Mexico, which I am not even going to try and pronounce. But welcome in, everyone. Great to see so many places and people from across the world joining us. As I said, for those just joining, we'll give it a few minutes for people to come in, and then we'll make a start. And I'm still going up, so give it a couple more, and then we'll dive in. Okay. We've got a busy agenda today, so starting to level out. So let's get started. Welcome, everyone. I'm Matt Woods. I'm the Senior Product Marketing Manager from Multiplayer Solutions here at Unity. I'll be your host for the webinar today. A couple of bits of housekeeping before we start. We're recording the session today, and we'll share that with everyone afterwards. We've got a couple of presenters and also a panel of experts that are here behind the scenes. We'll take your questions throughout the session, and then we'll have time at the end to answer some of those live as Q&A. In order to help us do that, if you can use the Q&A function in Zoom to ask any questions rather than the general chat, so we can collate any that are similar, make sure we don't miss any. And then please do use the sort of general chat function to raise any issues you've got or chat amongst yourselves, answer any questions between you as you would do. That's enough of me. So let me introduce our two speakers that we have today. I'm joined by Aaron Moon. He's a senior partner engineer on our multiplayer team here at Unity. Aaron's been in the hosting industry for over 20 years, had roles ranging from a developer to a CEO running his own company, and worked in many different hosting environments. In his time here at Unity, he's worked with hundreds of studios on their multiplayer games, preparing them for their launch and beyond. And we have Kiki Saintonge. Kiki's a senior product manager at Unity. She's been in the game development industry for over 10 years, and Kiki's responsible for our netcode stacks here at Unity. So super excited to hear from both of them. And without further ado, I'll hand over to you, Kiki.
Thank you. Hello, everybody. Let's get started. So I'll quickly go over our agenda, what we'll be talking about today, and then I will cover the first portion of this. So we're going to go over a little bit of what netcode is, how to use it, what network gameplay is from a very high level, and then take a look at how it's applied in a broad sense to a lot of the game genres. I know that some people have questions around what netcode is and how to use it and how it actually ties into the gameplay itself. It won't be super in depth, but it should be high enough that you, or deep enough that you should understand how it applies. But to help with that, Aaron will also be going over some of those genre-based infrastructure architecture and how that's applied to some games. And then we'll go into some tales from the trenches, and we'll use some more real-world scenarios on Aaron's part to sort of show you the exact application of that and how server and clients talk to each other. Let's get started with the overview of netcode. So what is netcode? Netcode is an abbreviation, a little bit of networked code. It's pretty self-explanatory there. If you take a step back and think about a fully networked tech stack, it actually contains two different aspects of it, two different layers. There's like a base layer called the transport. In Unity's case, we call that Unity Transport or UTP. And that's the base layer that manages all the traffic, the packets, it sends things to and from, and it can also communicate cross-platform. So you need some sort of transport to actually like send your data across. And then on top of transport, there's typically an abstraction layer that simplifies a lot of the common networking gameplay needs and integrates with any tools or the game engine you have. And this is agnostic to Unity itself. Usually that abstraction layer helps you to sort of understand how to communicate with that transport layer and how to translate a lot of your gameplay across the network so that everybody can see and play and have fun. So when we say netcode, oftentimes many people are referring to that second abstraction layer because that's where all of your gameplay is going to be coded. It's unlikely you'll touch the transport unless you need to do some really big optimizations. So when we say netcode, we are referring to that second one, but sometimes when people say netcode, they're referring to both of them. It kind of just depends on what you're using and where you're sort of starting out there. So what's important for networked gameplay in particular? Networked gameplay is how you use that netcode and how that applies to the actual gameplay yourself. So kind of merging that concept into two and calling it networked gameplay. So multiplayer game needs some three core aspects that you need to consider in order to sort of create a cohesive synchronization between what you're actually creating on the client and what everyone else sees and what the server sees and stuff. So there's three main aspects. One is who the host is or the clients are. It's important to know who's hosting and how the clients are connecting to that host or to each other, depending on your setup. Who has authority? So this is basically who has the ultimate say over what is actually happening in the game. So typically that's a server, but it could be whatever it is that you need to set up based on your gameplay. Again, very gameplay dependent. And then how your input will be received and reconciled. Since input is the main way that clients interact with the world, it's the most important part of networked gameplay. But you can also consider position and state depending on, again, the type of multiplayer game you're developing. So there are many different clever ways that you can approach these aspects that developers have figured out over the 20, 30 plus years that multiplayer games have been there. But again, it really is depending on what you need. You don't need every aspect possible in netcode, which I'll go over. You may need subsets depending on the complexity level you can handle and the type of game you're building. So let's cover hosting and authority. So hosting, I think everyone's pretty darn familiar with hosting. Many players set up their own servers so they can host their Minecraft servers or they can host their whatever it is that they're playing at the time. So the different variations that hosting comes in is the server hosted, client hosted, which used to be called a listen server, but client hosted is the most common use of that now. Then there's something called headless and peer-to-peer. Server hosted means that there's some big computer somewhere that has no rendering that's sitting out in the ocean and is receiving all the input and sending it out and making sure everyone's seeing the same thing. Client hosted means that a player is actually hosting the server as well as playing. A headless means that it's similar to server hosted, but it's a client that has no actual player there, but it's receiving input and is sometimes the authority as well. And then there's peer-to-peer where all clients are connected to each other and sharing data between each other. And then the authority model is closely related to hosting, but it kind of boils down to who do you trust? Do you trust the input coming in from all the different clients, or do you take all that input coming from the clients, validate it, and then send it back out? So it's either the authority model can either be like server/host authority, which means the host or server takes in all the info and determines whether or not it's correct, or it could be client authoritative, which basically means that whatever the client sends is the truth and we're just going to believe it and move on with our lives. Obviously, the client authoritative model is much easier to program and to manage, but the server authoritative model is much less security concerns. You have a lot more control over it. It's used in competitive games. It kind of depends on what you're trying to build and how much maintenance you want to maintain over time, because the server authoritative concept is tricky to set up and is tricky to manage and takes constant maintenance. So it's kind of know before you code and sort of figure out what it is you're trying to build. So if you're building more of a PvE, so your player versus environment, maybe you don't care as much about cheating as long as everyone's still having fun. But if you're doing a player versus player, you really want to validate that input and make sure that nobody feels like something was done in an unfair way. So finally, we'll talk about latency and synchronization. So this is arguably the hardest part of network gameplay, is understanding the sort of application of netcode concepts, which kind of come in the forms of adjusting for latency and making sure that everyone's synchronized. And this is really where it depends on the gameplay that you have in your game. You might want to synchronize a bit differently depending on if you have a turn-based game, or if you have a like fast-paced shooter, or if you have a racing game, or you have a lot of physics. Like synchronization is super important. And then latency, you need to adjust and sort of determine how much latency you're willing to handle, how much you can handle in your game, what makes it still fun to handle. Maybe some games can have a higher ping and get away with it. Some other games can't. So sort of playing that out. Playtesting will help a lot with this. But let's go over some of the netcode concepts that help compensate or adjust or make that gameplay feel better over the network in consideration of latency and synchronization. So some of these concepts are, and I'll go briefly over them, feel free to screenshot this or whatever, is prediction, or to predict, and reconciliation. Those typically tied together, but they are their own separate things. To predict basically means that the client does something, sends an input, changes its state, sends that out to the server or the host or whatever. But instead of waiting for that server to send information back so it can validate that what it wants to do is actually possible in the world, it just predicts what it thinks the server is going to do and does it. This kind of improves the client-based like local experience, because you hit that key and you immediately move and you don't have to worry about waiting for any like latency or perceived lag or anything like that. And then once it gets the validated state back from the server, it updates. And typically its prediction is correct if your connection is really good. If your connection is not very good, then you'll enter into a state called reconciliation, or to reconcile that. And that's typically server side. So the server or host is getting that input from clients, and it basically re-simulates that input that it got to sort of check to see if it actually is accurate. So if you have a bad input state, so let's say some client is malicious and they're trying to cheat, they'll send a bad input state to the server will take that input, they'll re-simulate it and go, that's not correct for me. I don't think you actually did jump there, because that means you're jumping through a wall. So then it's typically the server is the authoritative one, and it sends back and it goes, hey, you were wrong, so here, correct. So the client gets that updated information and it reconciles it. So the first is a prediction, just to sort of make it feel smooth on the client side. And the second is a reconciliation to make sure they're not sending bad input. So that's prediction and reconciliation. Those are really common and often used across many different genres, but they're not needed for every type of game. It really depends on the type of game you're making. Another concept is called rollback and or lockstep. Typically they're used separately. A rollback basically just means it re-simulates where the client should be if there was a large desync. So if you're playing a game and you're like running along and then suddenly you kind of snap back for a second, that could be a rollback in the past because you're lagging. Or if you're seeing another person run along and then they suddenly like snap forward or do some kind of rubber banding, that's usually a rollback happening. So that means the server received the state, realized that some people were lagging or some people weren't synchronized correctly. So it re-simulates and then jumps in one frame, corrects where that client should be, and then you see that little snap there. A lockstep is, again, a way to handle input, but basically just means that it freezes up everyone's input and waits until either a desync is corrected or all input is received by the host before it moves all the clients forward. So if you're ever playing a game where you like hit a button and you don't move and you keep hitting it, you're like, wait, what's going on? Am I lagging? Typically, you might be in a lockstep situation where it did get your input, but it doesn't have everyone's input yet, so it needs to wait milliseconds before it updates everybody. And these are ways to just adjust to make sure everyone's synchronized and that everyone's seeing the same thing at the same time, which is, or perceived to see the same thing at the same time, which is super important with network gameplay. Then there's interpolation, which is just as it sounds. It basically is a way to smooth out the movement of network objects between saved data. So I mentioned that rubber banding a little bit with rollback. So if you interpolate between that, instead of seeing a player snap to a new position, they'll just smoothly move to it. Typically the animation's always also in that interpolation. So it looks like a the rollback didn't happen, even if it did to you perceiving other clients. And it's just a way to make that whole visual experience a bit better. Server rewind, which is also known as lag compensation. We here at Unity call it server rewind. Is basically an operation that's performed server side, where it validates all the old inputs that the client's been at the times that the client states. So usually when the client sends off information, it has a timestamp on it. And it takes that and it re-simulates it and makes sure that certain things did happen at the time that clients claim they happened. So if you're running along, you hear a gunshot and the bullet goes by you, and you're like, oh, I missed it, and then suddenly you die. That was like a little server rewind happening. So they basically took your state and they took the person who shot you's state, and then they re-simulate it and they go, what, did he actually hit you at that time if you both weren't having lag? And yes, he did, therefore you're dead. That's a little server rewind that happens. Sort of helps with low ping on certain people's ends. And then lastly, we've got determinism, which basically just means given the same set of inputs, you get the same results. So rollback and lockstep is a version of determinism, but typically determinism is used for physics because physics can be very undeterministic. You can get a different reaction with a different set of values, but some engines have deterministic physics, which means given the same set of inputs, if the ball falls in the same way, the debris falls in the same way. And if that interacts with other clients, it's very important that they're all seeing the same thing, but you don't want to necessarily simulate all of that physics on the server, because then that can consume bandwidth and CPU and make things all slow. So you'd want that to run on the client side, but you want to make sure they're all seeing the same thing. So determinism is a way to do that. Again, not all of these need to apply to the game that you're making. It really depends. Like you may only need prediction and reconciliation, and the rest is not important to you. So kind of pick and choose these high-level concepts depending on what you need. But to help out with that, I did create a little table here. From a high level, we're looking at sort of the input type. Is it batched input? Is it real time? Like batch meaning, do you need to collect it all? And it's a turn-based game, so it doesn't really matter when it happens. Or is it real time? In which case, the time at which things are executed are super important. Then we've got sort of the high-level gameplay type, some game examples, and how they apply to those netcode concepts, both through host, authoritative model, and then some of those like interpolation and stuff like that. And then the associated like subgenres of each one. So I'm not going to go through all of these, and actually Aaron's going to be talking a bit about the genre architecture for network games and how this applies to it. So you'll see it in some actually like more in-depth examples a bit later, but if you want to screenshot this or whatever, you can take a look at it later to sort of see how things are applied. With all that in mind, bit of an info dump, I'm going to give it over to Aaron, who's going to talk about some of the genre-based infrastructure architecture for types of network games, and then go into some tales of the trenches. So I'm going to stop sharing and hand it over to you, Aaron.
Awesome. Thank you. And there we go. So that was awesome, in-depth kind of primer on some of the nomenclature that we hear about netcode. I think it's super important. There's a lot of confusion there. So as we talk more about genre-based infrastructure, definitely put your questions in the Q&A. Some of these concepts you may be familiar with. I'm going to try to keep it high level, not super deep dive, but we definitely want to help out. So put whatever questions you've got in there and we'll definitely address them at the end. So first, I'm going to talk a little bit about game client considerations. Now, when building multiplayer games, a lot of people don't think about the game client, but there are some things here that actually happen that might impact both the costs, the efficiency, and even might jeopardize launches if it's not well thought out. There's lots of maps and modes in a lot of game clients. We've even seen some folks build separate game clients for separate platforms, maybe different regional data. There's also anti-cheat. There's lots of things that you can kind of pack into that client. But keeping in mind when doing so, this may actually influence and impact some of your design when you're building out your server fleets. So just kind of a simple overview of some of the things you might find there. Assets are traditionally the biggest chunk of a client. So if you're building on mobile, you have limitations in size. There's considerations that need to be made there. And there's tooling that you may have to put in like CDNs just to kind of abstract some of that out. And as Kiki went over, there's netcode, there's transport. So all of those are native to your binary. It's good to kind of land on the right one when you're going that multiplayer route. And we'll talk a little bit about some of those netcodes and how they translate to some different genres. The game server fleet design is a really kind of a moving target, if you ask me. In my time at Unity, I've seen all kinds of different designs, and I've seen ways that they work well. I've seen ways that they could have gone a little better. So we're not going to name names here, but we are going to talk about some design considerations and maybe even some stories about how it went when people did launch with certain designs in mind. But, for this would be similar to what you would see in a persistent world server where you have session migration from one server to the other. These present challenges. These machines will be running 24 hours a day. They could potentially be attack targets and you can't move them. So you've got that. We've seen them mixed together in some of the popular MMOs where you have, actual session-based games inside of persistent games. And so we see a call out here to kind of like a raid situation. But there's lots of other design considerations as well. And your more session-based shooters, you'll see something more similar than this, right? A runtime that can be given a different flag to operate a different map or mode, potentially even a different type of gameplay. So these server sessions tend to be differentiated by version as well. So we've seen fleets where you can run multiple versions at the same time, which I highly recommend. But really, we've seen other things that we haven't talked about too much, and that's smaller than game server runtimes, things that host maybe a playable lobby. Maybe you've got a world server, maybe you've got a lobby that you can run around and do things with. Maybe there's even persistent data in there. And so we've seen those considerations as well. Keeping in mind that all these different types of server runtimes and different modes, they've got vastly different usage profiles. They use more or less CPU or RAM. And so that presents some scaling and design considerations as well. You also have, some advantages and disadvantages. When you're looking at maybe shooters, being able to shut them down rather than leaving them on all the time might actually present some cost savings. And so we've seen multiple ways that could be done as well. Game loop challenges. I think this is probably the biggest thing that influences the design of your multiplayer game. What is your gameplay supposed to be from the player perspective? Are you using a matchmaker or are you just connecting to lobbies and kind of picking from a server list? So in this diagram, it's kind of a shout out to a very complex situation a lot of people hadn't really thought about. And that's using a matchmaker for both lobby and a game server session. So just kind of a shout out to one of those games I won't name, but in this situation, you'd basically be hitting a matchmaker to get into a lobby. Once you're in that lobby, it is kind of a world. It does have persistent data. And then from there, you might find a game server session with other players. Once you're done, you go back to that matchmaker and you get matched into another lobby. So it's an interesting kind of data flow. And we'll even talk about a situation where this is happening in a game. And we'll go over what the actual hardware and connectivity looked like. But when you're building things like this and you're using your game loop, you have to understand, how does it scale? Do each of these lobbies and game servers, for example, scale independently? Are they in lockstep? Are they packed in the same machines? Maybe they need to run on a different server binary. Maybe that lobby is a lot smaller and you want to fit more of them on a machine just to reduce costs. Are they persistent? Are you saving state data to a database? There's a lot of things here that's going to influence that. And then definitely size is a thing. So if you have a huge multiplayer game that encircles the world, how are you going to regionally disperse all of this infrastructure? And again, at the end of the day, when you take all these game loop challenges and design considerations into play, how much money are you actually going to be wasting? Is there a way to optimize? So things like that can definitely prematurely shut down a game because the budgets get blown up. So we talked about this in the last webinar that we did, and that was kind of like server tessellation. And this is an allusion to what we just talked about a little bit ago, and that's that kind of server packing problem. We have lobbies, maybe they're smaller. We have larger maps that consume more resources. So these challenges right here are definitely solved if you've got a good hosting provider, somebody that understands games that can actually help you out with this. So in addition to, client server and game loop, you definitely want to consider where you're actually putting these sessions and how you can optimize it. Some platforms have limitations, so it's a good idea to really be thoughtful about this decision. For us, we're going to talk about just two games. These are real world games. We're not going to name titles, but we're going to take a look and pull back the curtains, if you will, on some of the backend infrastructure and what it looks like. The first one is basically going to be a persistent world game. You might hear things here that'll clue you in on what it might be, but we're not gonna name drop. It's not Zenith, so we did want to make sure that we mentioned that. This one is more of an open world, persistent world data. And what I mean by that is, if you chop down a tree in this world, everybody's going to see it. So that state has got to be saved somewhere, pushed up to a database, and that presents its own kind of challenges. Server to server migration is possible, so players can actually go from one server instance to another. We're going to talk a little bit about the netcode for this. This is a dedicated game server model, and it is server authoritative, and there is prediction and reconciliation involved in this. And that's because there's, a bit of battling. So things like that definitely need to be sussed out with that client server connectivity that we discussed a minute ago. There are some noteworthy components here, things that you should shout out for just persistent world games, and that's that database layout. So we're going to talk a little bit about that and how important it is. Game launchers, probably not something you'll see in a lot of games these days. That's more of a MMO-esque kind of design consideration. But these can also be packaged with, lobbies, server lists, leaderboards, lots of different things. And then, web application firewalls. We talked about how open world, persistent machines, they don't change their IPs, right? They're always on. So they become targets. So having to really think about how to protect that session for the players to preserve that player experience is kind of difficult and sometimes expensive. And that's kind of more alluding to the challenges, right? In open world games, a lot of people don't understand the huge bandwidth costs that are at play here. As you're saving that state and as players are dropping in and that's being loaded into their client, that's a lot of data. So if you're in cloud, how much more does that cost? When you're patching a game that's always running, how does that infrastructure translate? Do you have to stand up empty servers, empty machines, and then kind of bleed over? Or did you take into consideration maybe allowing the opportunity or the ability for multiple game versions to be running simultaneously? Maybe you can kind of bleed over in a more cost-effective way. And of course, with MMOs and all that state data and maps, those are loaded in memory typically. Whether you're on Unreal or whether you're in Unity, that starts to balloon. So that can limit instance counts on machines. So then you start to have to think about, well, how much do I actually want to load? Is there more efficient ways to do this? And then the cheating thing, well, when any competitive situation arises in games, there's always people trying to push the envelope of what's possible. So this game loop was really simple, at least it seems, right? You got a launcher, you got those game clients that are loaded up. They're probably instantly put into a social lobby in this situation. And then they're presented with, server list and some news panels and things like that. So for them, it's simply pick a server from the list. There's no matchmaking. They'll hit that world server. Once they're done, they'll go back to that lobby, rinse, repeat. And this situation, they can also go from server to server. So maybe there's a raid going on somewhere and you want to go over there and destroy somebody else's base. So in this situation, there had to be considerations for how do we handle session migration? What does that look like? What challenges would it represent? So for this matchmaking flow, it was simple. Now, when we actually start talking about the back end infrastructure to make it simple, well, not so simple. So this is just an example of what can be done. By no means is this really the recipe for success or failure for that matter. But just to talk about some of these pieces, I'm going to break it down. So that launcher, there's a lot of companies out there that will build their own. There's some that have third-party launchers. Regardless of that, the problem we're trying to solve is we want the ability for people to collaborate in that lobby. We want them to be able to pick from a world list. And then in this one specific game, there was actually a client database that was local on the player's machine. And this was what was handling that real fast synchronous data. So basically they would load up the game. When they were playing, that client database would be capturing all of the state changes rapidly. This was so that if a client crashed, it never really lost the data. Obviously, there's ways to secure that. And so then it would asynchronously update that regional database. And in this game, they basically had multiple per region. So one in America, one in the European, and one in the Asia regions. So what this allowed for was the preservation of data. It also made things really fast, and it eliminated a lot of lag contentions. Social lobby and world lists allowed them to connect to game servers, but as we said before, there was problems with them being attack targets. So when we go down to this layer here, it actually implemented some kind of a private WAN. So think of like a Cloudflare, something to cloak the IP. Now, that wasn't what they used, but what they used also had a DDoS filtering solution built into it. Coming from the hosting space, we really enjoyed selling things like that because they were extraordinarily expensive. When hosting an MMO, something like this, that presents also a huge challenge. So we'll talk about how the dust settled on that decision in the later slide. But let's kind of go into what this server architecture looks like. So you'll notice here, there's no matchmaking. There's not a lot of defragmenting going on. So the player base is kind of scattered. There's some servers that maybe just don't have a lot of population. And, maybe there's wasted compute there. Maybe they're not using as much CPU and RAM as they should. And so there's some white space. Maybe you have some servers that are just running and they're completely empty. Hopefully they're not in cloud because that's costing you money. And also still there's maybe another server that's just got a whole bunch of players on it, right? Maybe there's a raid going on. There's a lot of traffic. Lag is definitely something that we want to consider here, which is why we talked about the netcode considerations earlier. And, then you've got this update situation. So for this particular customer, when they were updating their game, they actually had to spin up like a version 2 of their bare metal fleet. So for a while, they actually doubled their infrastructure. And so that presented a huge cost challenge. So even updating a game, which should be cheap and it should be easy, didn't happen very frequently because of that cost. So player engagement, bug squashing, things like that, they happened at a slower cadence. That can definitely have an impact on your player population. But each of these things, kind of presented a solution to a myriad of problems in hosting a persistent world or open world game. The second one we're going to talk about is pretty popular. We could probably name drop a whole bunch of different shooters we've hosted. We're not going to. There's a lot of similarities with a lot of other battle royale games, but that's specifically what this one is. So it is kind of a battle royale. It's a drop-in, drop-out matchmaking. Had a lot of other interesting tidbits in here, like a playable lobby, where actually, like we had discussed before, you're making state changes in that world, and it actually persists. So matchmaking people in and out of a lobby could be a challenge there, especially if you have to bring in their state data. These servers, for whatever reason, were actually online in between sessions. So they never shut down. They never restarted in between games. And so they implemented a session cleanup logic to handle that. There's a disadvantage to that, and we'll go over it. Server binary for all modes, maps, and platforms. Now, in some situations, that's not possible. Maybe you have different platforms. Maybe you have maybe smaller or bigger maps, and you want to split that out. But this specific customer actually was able to package all of those different things into one single server binary and one client. So it made it super efficient. It also made the update target easier to manage because you didn't have a whole bunch of versions and forks for different images. Although this infrastructure was designed to independently scale, and they separated a lot of these different maps and modes into different fleets so that they could independently grow and shrink based on player demand in the game loop. Understanding the netcode piece here, now we're starting to get into the serious territory with netcode. So flexing its muscles with, some kind of rollback netcode, which is what this customer used, they're definitely server authoritative. There's a need for that interpolation, that prediction, reconciliation, and even server rewind. There's an opportunity for the server to start using compute to actually replay what has happened, so it can make sure if it needs to correct state that it does. So there's actually an impact to the server on that, which we'll talk about. Noteworthy components for this, you've probably heard of these things before. Playable lobbies, not a new thing. The fact that the sessions weren't restarting in between games is kind of different. Most shooters will basically end their game server runtime on player exit and shut it down. And there's a scaling advantage to that. The rollback netcode piece, there's different netcodes for shooters, and there's a lot of debate on which one is the best. The key here is just to make sure that you're aiming for the kind of player experience you want, and you have that netcode being taken into consideration to solve that. Challenges and issues for these guys were many. So these games tend to be on the larger end of the spectrum. So more players means more problems, more back-end scaling issues. So redundancies, things like that have to be put into place. So it tends to be more expensive on the back-end infrastructure side. These are fast-paced matches. So that cleanup in between sessions, let's imagine that's happening in cloud. You're using compete egress. So all of those are billable items. So maybe it makes sense to do this on more bare metal than cloud. The matchmaking logic is also really complex. So, this customer had multiple different matchmaking algorithms that they would use, or match functions. So they had to constantly look at, was this actual match function something that's being used? Is it efficient enough? Is there a better way to do this? And in tuning and tweaking that, it also impacts, that player flow or that game loop. We also had constant frame drops. So whether it's on the client side or whether it's on the server side, being able to troubleshoot through that, you definitely want to have some partnerships in the multiplayer space to solve some of those problems. So putting up monitoring capabilities with your server fleets, understanding, is it a machine issue or is it a code issue? Again, more design considerations, because the more you're putting on the server binary, the less servers are going to fit on a machine. Now, the high update rate here with the complex netcode definitely impacted CPU. So we watched this customer actually switch netcodes. It was really interesting because the impact of that actually lessened the number of game servers that they could run on a cloud instance or a bare metal box. And so that impacted costs, and they hadn't considered that. So they had to make other considerations and changes to the game client and server to actually compensate for that so that they could pack more instances. So efficiencies like maybe turning down the tick rate, maybe reducing some of the analytics tools in the back end. There's a lot of tactics there to solve some of those issues. The player lobby population has always been a problem. If you think about a big lobby, maybe you want to have hundreds of players in there because they are interacting. But maybe you have a lobby that just isn't being used. And so it's got, maybe 1 or 2 players in it. So how much space are you wasting? You need to maybe session migrate them to a lobby that's got more people. How would you handle that problem? So those challenges there we're also going to check out. The game loop for this is, again, looks very simple, and that could be deceiving, but the clients would basically hit the matchmaker for a lobby. Once they were in that lobby, they would hit that matchmaker there, and they would hit that game server. And then that would repeat, right? Once they're finished with that session, they would matchmake back to a lobby, which would then allow them to matchmake back to a game server instance. And so that was a continual recycling there. Now, the challenge behind that is that, you have huge player populations rolling through your matchmaker. So everything there has to be efficient. The server instances that you have up have to be able to scale both a lobby and a game server. And so that presented some challenges. Maybe this looks a little more elegant than the last one. Most MMOs are kind of complex, and some of the battle royales are maybe a little bit leaner, if you could. So because we're not doing persistent worlds, right, and we're actually wiping these things, we can represent all these game server instances here, these tiny little boxes, as kind of cattle. If something happens to one of them, it does impact a small number of players, but we can simply spin up another one, no harm, no foul. Largely, the player population is unaffected game-wide. So here you can see that the matchmaker is kind of the center post of everything in the infrastructure. So having that real robust matchmaker that supports different match functions, like quality of service, where you want to match maybe to a machine or a data center that's actually got better ping for you. And maybe even though there's players on other areas, you don't want to have to deal with lots of lag. Maybe you have a social team or a hub and you all want to play together. So that matchmaker in this situation had to consider team-based or social-based matchmaking. And then obviously, because most of us don't like getting beat up by all of the younger generation that's got really fast reflexes. I know I don't like to hop into a shooter and get wasted in 30 seconds or 3 seconds. So MMR was basically a thing. So, ranking people and players and being able to matchmake preserved the player experience for a lot of these players. So people like me could be matched with people who are just as capable or incapable as I am. And so, I had a chance. So made it a little bit more fun. And we actually saw the impact of those match functions on the actual player populations. It was pretty interesting to see the increase in engagement. And then backfill. Some of these game instances actually did have players drop out. And for whatever reason, this customer wanted the ability to fill those sessions with players so people could jump in and out. It's an interesting concept, but it also was needed for lobbies, right? Because you need to backfill people in the lobbies. You didn't want to run that lobby with just one player. So a lot of different technology here wired together to support this session-based shooter. if we zoom in to the actual server instances, this is where we start solving some of the efficiency problems with updating and running games as a service. So this customer actually did support running multiple versions and multiple platforms all with the same client. And that allowed them to basically run different versions, QoS, dev environments, all on top of production. So there was never any need to spin up additional infrastructure. So that right there was a huge cost savings for them. It also meant that they could continue to update without impacting their budgets, because it was pretty much a free system. They're using the infrastructure they already have. And as you can see here, they also took advantages of some ways to scale down. So you can see the cloud offline over here. And that's basically because they were putting in logic that would actually exit when there were no players in an instance, and that would spin that instance down. And then it'd allow that cloud machine to then go ahead and be sunset for a while until it was needed again the next day. And you could see here, packing all those maps and modes was probably a good idea, right? Having to manage one server instance and just give it a flag to run in a specific profile is pretty common. And then we see with customers like this, hundreds and hundreds of different profiles. So that made it easier to manage one binary with all these modes. It also made it easier to scale because you didn't have to have a whole bunch of storage for different game server images. So when we talk about both those situations from a high level, we're going to talk about some of the challenges and the solutions that were implemented. So back in that persistent world game, we looked at the fact that these were running all the time, and cloud is more expensive. Bandwidth is a huge cost, and in cloud bandwidth is the huge cost. So they decided against cloud and actually went 100% bare metal, understanding that they would have instances that they needed to kind of keep in buffer. And there was still the ability to scale into cloud if they absolutely had to. So they picked a good partner to help them with that, and that reduced a lot of cost. They implemented multiple versions to be able to run at the same time, as we talked about in the previous one. That's a good idea all the way around. So this allowed them to patch with no downtime and no maintenance mode, which is something we're seeing more and more in MMOs, and highly recommended that you do. And that just allows you the ability to kind of back and forth. If you have a bad patch, you don't have to matchmake or populate a server list with those versions. You can just kind of pull it back, and the player population still has a game to play, and they're not waiting. The encrypted communication channels to and from the server and client were important. What was actually found was with that more open world game, customers were able to figure out what the server IP was, and this was their attack vector. So just simply putting some encryption in there to not be able to replicate traffic because they couldn't see what the packets actually looked like. And the fact that we cloaked the server IP by using something like Valve SDR meant that they no longer had an attack target and eliminated the majority of the attacks. So they were allowed to pull that DDoS WAF solution out of there, which represented a huge cost center. So that is going to continue to keep that game up and running for the long term. And it's definitely, if it works for you, that's probably the cheapest way that you could mitigate those types of situations. So the scenario 2, that session-based shooter, they changed it up, right? Rather than keeping that server runtime running all the time in between sessions and just cleaning up, they simply had a exit 0 added to their server runtime. So when the last player left the runtime did a check, said there's no players here, I'm going to go ahead and request an exit. That process shut down, didn't need to be cleaned up. And so that actually allowed them to scale down a lot faster in cloud and save a lot of cost. They also, again, implemented support for multiple versions to run at the same time, and again, empower that zero downtime patching we spoke about before. Now, the other interesting thing here is, unlike that MMO where you've got world servers and they're all kind of different, these guys actually broke out some maps and modes into different fleets. So, like we talk about the lobby that might only have one player in it, separate fleet for that. And so that made it more efficient. It eliminated a lot of the white space, and it allowed them to scale it predictably. If you're trying to fit this big giant instance of a runtime for the game and then this tiny little instance for a lobby, and you're trying to fit them next to each other, you might have a lot of white space there, and there's some complexities. So we decided to split those out into other fleets. The playable lobby piece was really only bare metal. And we kind of determined that if I'm only going to have one player there, why would you want to spend a whole bunch of money in cloud running this idle or barely populated server instance? So these were some of the things that were done for these 2 titles. Obviously, there are a lot more situations that you're going to run into when you're scaling a multiplayer game, but hopefully this gave you a good idea of some of the design considerations, the challenges, and some of the ways to solve some of those problems. So with that, definitely want to kick it back over to Mr. Matt, and we'll do some Q&A.
Thank you, Kiki, and thank you, Aaron. That was super interesting. I hope those on the call found it as useful as I did. Questions coming in on the Q&A. I know we've had quite a few in already, so we'll get through as many of those as we can in the time left. As I said at the start, we'll be sending over the recording and the presentation to everyone by email in the next few days, so do keep your eyes out for that. But we'll let Kiki and Aaron have a brief sip of water. I'll hand you over to Dan Richards, one of our senior software engineers on the multiplayer team, who will moderate the Q&A. So what questions have we got coming in, Dan?
Hey, folks. Yeah, so we've got about 6 or 7 questions in the chat, which is cool. So I guess to kick off, we had a question from Dakota. Is this a replacement for UNet? I'm guessing that was framed around your sort of starting content, Kiki.
The concepts that I was covering are kind of netcode implementation agnostic, which means I wasn't referring to any particular one. But if you are curious about the netcodes that Unity supports and has available today, there's actually 2. One is netcode for game objects, and one is netcode for entities. As those names imply, one is for the game object-based system, the other one's for the DOTS architecture, so data-oriented tech stack or entities tech stack there. So it kind of depends on the architecture that you're building your multiplayer game on top of. As far as a replacement for UNet goes, either one is a replacement, again, depending on what you will want to build. If you're building more competitive, go for the entities. If you're building something a little more casual, more co-op, go for the game objects.
Nice, thank you. Aaron, did you want to build on that at all?
I think she covered it pretty effectively. I will say that, we do have some samples specifically for Unity for Mirror. So we have actually got a couple samples in there for Lobby and Relay. So there is a Mirror UTP sample available. Some of our technology is also pluggable into other netcodes that are not supported specifically on Unity. So keep that in mind. Netcode doesn't have to be engine specific. There are lots of considerations out there.
Nice, good call out. And this actually leads us very nicely into the next question, which is specifically around dots. So it's quite a long question. I'm gonna summarize a little bit of it, but basically we're saying dots offers an interesting abstraction system for splitting up client and server logic while running performance systems on either side. However, dots seems to currently lack maturity for hybrid games, in so much that those games that want to use the architecture not for performance reasons, but for architectural benefits like 2D tile map games. It seems that hybrid developers using dots would need to rebuild very large parts of the engine to reap the kind of ECS benefits, up to a point where we're going to see diminishing returns. Are there any focuses on the ongoing improvement for hybrid apps, or is it generally discouraged to go hybrid at all at this stage?
That's one for me as well.
Yes, I think so, Kiki.
Okay. So I'm not super familiar with your specific terminology for a hybrid game. Typically when I think hybrid, I think of like hybrid mobile apps. But to answer the question more directly, yes, there's always efforts being put in to improve the DOTS architecture, specifically because it's still relatively new. So there's lots of avenues that we still, we went 1.0 last year, which means you can now take production bets on it. We're fully supporting it. It's moving forward, but there's still, yes, a lot of work to do. So if you're finding some frustrations right now with just sort of some extra like engine related debt, yes, we're looking into all of that. There's a huge backlog of things that we want to put in to catch that up to what you might expect from a game object based tech stack.
Yeah, absolutely. And I think the other reading of hybrid from that question is potentially around hybrid authority models, whether we're blending a server authority or host authority, or listen server, Dedi server. I think that maybe is the other reading of that question. I think, Aaron, maybe you have some insight on that one.
Not a netcode engineer. I'll just say that, one thing that I want to hammer down on is that we have a customer product relationship that we're very interested in nurturing. So when you have considerations and questions like this, definitely we want to address that, because we have product teams that definitely want to hear what your thoughts and challenges are. So we're definitely going to take some of that information back to some teams internally, and maybe we can find a way to follow up outside of this call. But it's a really good question. I personally want to see an answer to that one.
Yeah, +1 to that. Okay, next question was around, looks like a card game. So if we're building a card game while using netcode or other library, sounds good for building the clients, but the server can hold a lot of games as well as lobbies. Other libraries allow you to have more than one running Unity executable to handle all of that. Netcode does not allow that. You mentioned REST servers in the slides. Do you have resources to look into building these?
I could probably tackle part of that. Yeah. So really simply, like card games like that, hyper casual. We've actually seen people put multiple separate games in one single runtime, both server authority models and peer-to-peer. And so I can definitely understand the challenge. I would just say this, that, the netcode consideration itself, again, does not have to be locked into what Unity provides. There's definitely other options out there. I think, sorry, the question disappeared, so I might be missing some of the context there.
That's my bad. I might have accidentally accepted the question before you were done answering.
No worries.
I think,
yeah, repeat the context, sorry.
Yeah, I think it was mostly around the resources for building the REST servers side of things, as opposed to the kind of netcode server side of things.
So REST servers, I kind of think of like Relay. So we do have a product in Unity called Relay. Definitely want you to take a look at that. It uses a specific transport protocol, the UTP, I believe, Kiki. And we've also got, again, that built into Mirror, and there's other netcode considerations. So that may actually work for you. If not, there's hybrid ways of doing that, right? There's a way to mix different netcodes and different runtimes. So maybe there is a need for two separate runtimes for two different play mechanics.
Yeah, good call out. Okay, question from Kevin. I think this one will be for you, Kiki. Is there support for network relevance? Example, player A is inside a building, player B is outside. A opens the door, B's client should get the state of the door, but the sound shouldn't play. So sort of spatial awareness, I guess, there in the netcode.
I think we call that area of interest, or AOI, if I'm understanding correctly. But I mean, with networking, there's so many different ways to refer to the exact same functionality. So network relevance may be another terminology for it. So the particular example that you're giving is partially how you implement it yourself, and partially could be something built into the netcode. I know for netcode for game objects, we don't have any area of interest related support in it. For netcode for entities, I believe there's a lightweight version of it, but there's still some work you'd have to do on your end, depending on if you're server authoritative or if you're client authoritative. So if you don't want a sound to play, then just don't build sounds into the server, and then it won't be sending out any messages for that. So it kind of depends on the exact situation you need. So that's the tricky thing with netcode, is that it literally just gives you interesting ways to handle synchronization and to handle latency, and to potentially integrate some networking behaviors into your gameplay yourself. But it's not going to give you an exact solution to this exact situation of opening a door, because then we're kind of prescribing the gameplay to you, and then that's going to limit what you can actually build. So in your particular example, some of it, like if we did build in the area of interest or the network relevance into the netcode, all it would do is say like, hey, this thing happened, but you'd still need to put the rest of that particular interaction that you're looking for into the netcode itself. So we don't support in game objects. I believe we do it in entities.
Nice. Yeah, that makes a lot of sense. So it's all about separating the concerns there, I guess, isn't it? Like netcode isn't going to solve all of that for you, but giving you at least the tools to solve it yourself.
Yeah.
Nice. Okay, so I think another one for you actually will be around ML API and where we are sort of today with NGO and with dots as well. So we have an old game on the ML API, which seems to be similar to netcode, but maybe using an outdated version. How much of netcode is different in terms of performance and features? And is there a migration path between the two?
Oh gosh, it's a little bit before I joined, so I'm not entirely sure about migration plan, but I do know that I don't believe we deprecated anything major from ML API, and we definitely improved a lot of the performance when we added more features into it. So I think things like the network manager, network objects, if you have that stuff set up, should still transfer over. But I would poke around our documentation to see if there's a migration plan, but I can also look myself if is there some way to follow up with this group or to post some like afterthoughts for this, so there are resources that people are asking for that can follow up with that.
Yeah, we should be able to do that, Kiki. We've got people's contact details and the registration, so we can reach out specifically, and we can also utilize the forums as well where possible to go into a bit more detail with posts to various resources that we have.
Okay, it looks like you also posted some upgrade from ML API into the chat there, so that might be something to look into as well. But it is very similar in a lot of ways. So a lot of the concepts and things that you learn from ML API should be applicable to netcode for game object. You may just have more netcode support or some changes to maybe some network variables or network transforms and that kind of stuff.
Yeah, wonderful, very nice. Yeah, plus one to that, always recommend digging through the documentation where it's all possible. We've got a great documentation and technical writing team to cover off a lot of this stuff, which is cool. I think some of this next question might actually be covered docs-wise as well, but this is a byte ordering question. So is it viable to support only little endian client machines who've been able to get significant performance boosts when it comes to state serialization via that assumption?
I would say cool. Like it really depends on who you think is going to be connected to your game and who's playing. Like if you expect everyone to be on little endian and that's what you want in terms, and you're seeing a performance improvement and it's not affecting other people's gameplay or limiting the type of like user acquisition that you can get on your product, then go for it. Like absolutely, it should be. That's an awesome solution to something, but I don't think it's netcode specific. What do you think, Aaron?
Well, one, I like it when people make suggestions like this. So I definitely think that should be posted on one of our forums. So kudos for somebody putting that out there. I've seen lots of different serialization types that work better with server authoritative designs. I mean, really, when it comes down to multiplayer games, it's test, retest, test, retest. So continue pushing the envelope there. And obviously, you know, if I'm going to talk Unity specific, we have a team of people that will help with that. Definitely reach out to one of us. We'd love to kind of take a look at what you're doing. And if you have problems scaling or you want to do any of those types of testing, we definitely have teams who can help you with it.
Nice. Thank you both. All right. So Matt, we're pushing near to the top of the hour. How much more time do you think we have for questions?
I think we can squeeze maybe one more quick one in, if there is such a thing.
Yeah, we can probably manage this next one. Okay, so a good question here from Chris. From my understanding, Call of Duty uses listen servers for many years. Even the most recent titles can fall back to a listen server model when dedicated servers are unavailable. Could indie developers take a similar approach to avoid betting everything on the ongoing costs of running a dedicated server fleet? So again, coming back to the hybrid point from earlier.
Yeah, I've got this one. I mean, I've seen a lot of this. Actually, using relay or listen servers is pretty common in the industry. And I've seen games use it both ways. You know, for example, you've got like this really popular shooter. Maybe it's not so synchronous. Maybe it doesn't need really performant netcode or high refresh or tick rates. So in that situation, a lot of times they'll fall back to something of a listen server or relay server model. And they'll do that just to kind of squeeze costs. So as you long tail in numbers, you know, you make optimizations. Some of those are cost optimizations. And so I've seen that actually happen. In some situations, you mix it together. Maybe that lobby that we discussed earlier doesn't need really performant netcode. Maybe it doesn't need a dedicated server. Maybe it just needs a listen server. So there's many ways to kind of mix those two. I think we actually had a GDC talk on this a while back. So we could probably pull up some archives there and push that out.
Yeah, great call out. I think you know, another example of that would be the Soulsborne series of games like Dark Souls and Elden Ring. Like the PvP in there uses a dedicated servers, whereas your main kind of overworld PvE and with less high sort of tick rate stuff is relay. So yeah, definitely a horses for courses kind of situation. All right, so I think we're just about running out of time, so I think we'll have to call it there for questions. So thank you for everybody who put a question in. Sorry if we didn't quite get to you, but we'll be able to follow up after the webinar ends, more than likely. So I'll hand you back to Matt.
Amazing. Thank you, Dan. Thank you, Kiki. Thank you, Aaron. That was bang on time as well. Thank you to everyone's attending. And as I said, keep your eyes peeled on your inbox for the recording and these slides. And yeah, engage with us on the forums, read the documentation, and we hope to speak to you again in the near future. Thanks very much, everyone. Cheers.